Jump to content. Main menu. Main menu. Move to sidebar hide. Navigation. Main page. Contents. Current events. Random article. About Wikipedia. Contact us. Contribute. Help. Learn to edit. Community portal. Recent changes. Upload file. Search. Search. Appearance. Donate. Create account. Login. Personal tools. Donate. Create account. Login. Pages for logged out editors. Learn more. Contributions. Talk. Contents. Move to sidebar hide. Top. 1 Etymology. 2 Early studies. Toggle early studies subsection. 2.1 Early theorists. 3 Psychology. Toggle psychology subsection. 3.1 Piaget's theory of cognitive development. 3.2 Beginning of cognition. 3.3 Common types of tests on human cognition. 3.3.1 Serial position. 3.3.2 Word superiority. 3.3.3 Brown-Peterson. 3.3.4 Memory span. 3.3.5 Visual search. 3.3.6 Knowledge representation. 4 Metacognition. 5 Improving cognition. Toggle improving cognition subsection. 5.1 Physical exercise. 5.2 Dietary supplements. 5.3 Pleasurable social stimulation. 5.4 Other methods. 6 See also. 7 References. 8 Further reading. 9 External links. Toggle the table of contents. Cognition. 78 languages. Afrikaans. Asturiano. Eisenbakenka. Bosanski. Catala. Etina. Cymraeg. Dansk. Deutsch. Easti. Emiliani Romagnol. Espanol. Esperanto. Euskara. Francais. Gaelge. Gallego. Hrvatski. Bahasa Indonesia. Italiano. Latina. Latviu. Liatuvi. Magyar. Bahasa Malay. Netherlands. Norsk Bokmål. Norsk Norsk. Uzbeka / Polski. Portuguese. Rom. Shchip. Simple English. Slovenina. Slovenina. / Srpski. Srpskovatski / Suomi. Svenska. Tagalog. / Tatarka. Turks. Tingvit. Winare. Edit links. Article. Talk. English. Read. Edit. View history. Tools. Tools. Move to sidebar hide. Actions. Read. Edit. View history. General. What links here? Related changes. Upload file. Special pages. Permanent link. Page information. Cite this page. Get shortened URL. Download QR code. Print / export. Download as PDF. Printable version. In other projects. Wikimedia Commons. Wikidata item. Appearance. Move to sidebar hide. From Wikipedia, the free encyclopedia. Act or process of knowing. This article is about the mental process. For the journal, see Cognition, Journal. See also, Animal Cognition. Cognitive redirects here. For other uses, see Cognitive, Disambiguation. A cognitive model, as illustrated by Robert Flood, 1619, 1. Cognition is the mental action or process of acquiring knowledge and understanding through thought, experience, and the senses. 2. It encompasses all aspects of intellectual functions and processes such as perception, attention, thought, imagination, intelligence, the formation of knowledge, memory and working memory, judgment and evaluation, reasoning and computation, problem solving and decision making, comprehension and production of language. Cognitive processes use existing knowledge to discover new knowledge. Cognitive processes are analyzed from different perspectives within different contexts, notably in the fields of linguistics, musicology, anesthesia, neuroscience, psychiatry, psychology, education, philosophy, anthropology, biology, systemics, logic, and computer science. 3. These and other approaches to the analysis of cognition, such as embodied cognition, are synthesized in the developing field of cognitive science, a progressively autonomous academic discipline. Etymology. Edit. The word cognition dates back to the 15th century, where it meant thinking and awareness. 4. The term comes from the Latin noun cognitio, examination, learning, or knowledge, derived from the verb conosco, a compound of con, with, and gnsc, know. The latter half, gnsc, itself is a cognate of a Greek verb, nosko, gamma, I know or perceive. 5, 6. Early studies. Edit. Despite the word cognitive itself dating back to the 15th century, attention to cognitive processes came about more than 18 centuries earlier, beginning with Aristotle, 384–322 BCE, and his interest in the inner workings of the mind and how they affect the human experience. Aristotle focused on cognitive areas pertaining to memory, perception, and mental imagery. He placed great importance on ensuring that his studies were based on empirical evidence, that is, scientific information that is gathered through observation and conscientious experimentation. 7. 2 millennia later, the groundwork for modern concepts of cognition was laid during the Enlightenment by thinkers such as John Locke and Dugald Stewart, who sought to develop a model of the mind in which ideas were acquired, remembered and manipulated. 8. During the early 19th century, cognitive models were developed both in philosophy, particularly by authors writing about the philosophy of mind, and within medicine, especially by physicians seeking to understand how to cure madness. In Britain, these models were studied in the academy by scholars such as James Sully at University College London, and they were even used by politicians when considering the National Elementary Education Act 1870, 33 and 34 Vict C 75. 9. As psychology emerged as a burgeoning field of study in Europe, whilst also gaining a following in America, scientists such as Wilhelm Wundt, Hermann Ebbinghaus, Mary Whiton Calkins, and William James would offer their contributions to the study of human cognition. Citation needed. Early theorists. Edit. Wilhelm Wundt, 1832–1920, emphasized the notion of what he called introspection, examining the inner feelings of an individual. With introspection, the subject had to be careful with describing their feelings in the most objective manner possible in order for Wundt to find the information scientific. 10. 11. Though Wundt's contributions are by no means minimal, modern psychologists find his methods to be too subjective and choose to rely on more objective procedures of experimentation to make conclusions about the human cognitive process. Citation needed. Hermann Ebbinghaus, 1850–1909, conducted cognitive studies that mainly examined the function and capacity of human memory. Ebbinghaus developed his own experiment in which he constructed over 2,000 syllables made out of non-existent words, for instance, EAS. He then examined his own personal ability to learn these non-words. He purposely chose non-words as opposed to real words to control for the influence of pre-existing experience on what the words might symbolize, thus enabling easier recollection of them. 10.12. Ebbinghaus observed and hypothesized a number of variables that may have affected his ability to learn and recall the non-words he created. One of the reasons, he concluded, was the amount of time between the presentation of the list of stimuli and the recitation or recall of the same. Ebbinghaus was the first to record and plot a learning curve and a forgetting curve. 13. His work heavily influenced the study of serial position and its effect on memory. Citation needed. Mary Whiton Calkins, 1863–1930, was an influential American pioneer in the realm of psychology. Her work also focused on human memory capacity. A common theory, called the recency effect, can be attributed to the studies that she conducted. 14. The recency effect, also discussed in the subsequent experiment section, is the tendency for individuals to be able to accurately recollect the final items presented in a sequence of stimuli. Calkins' theory is closely related to the aforementioned study and conclusion of the memory experiments conducted by Hermann Ebbinghaus. 15. William James, 1842–1910, is another pivotal figure in the history of cognitive science. James was quite discontent with Wundt's emphasis on introspection and Ebbinghaus' use of nonsense stimuli. He instead chose to focus on the human learning experience in everyday life and its importance to the study of cognition. James' most significant contribution to the study and theory of cognition was his textbook Principles of Psychology, which preliminarily examines aspects of cognition such as perception, memory, reasoning, and attention. 15. René Descartes, 1596–1650, was a 17th-century philosopher who came up with the phrase cogito, ergo sum, which means I think, therefore I am. He took a philosophical approach to the study of cognition and the mind. With his meditations he wanted people to meditate along with him to come to the same conclusions as he did, but in their own free cognition. 16. Psychology. Edit. When the mind makes a generalization such as the concept of tree, it extracts similarities from numerous examples. The simplification enables high-level thinking, abstract thinking. See also, cognitivism, psychology. In psychology, the term cognition is usually used within an information processing view of an individual's psychological functions. 17, and such is the same in cognitive engineering. 18. In the study of social cognition, a branch of social psychology, the term is used to explain attitudes, attribution, and group dynamics. 17. However, psychological research within the field of cognitive science has also suggested an embodied approach to understanding cognition. Contrary to the traditional computationalist approach, embodied cognition emphasizes the body's significant role in the acquisition and development of cognitive capabilities. 19. 20. Human cognition is conscious and unconscious, concrete or abstract, as well as intuitive, like knowledge of a language, and conceptual, like a model of a language. It encompasses processes such as memory, association, concept formation, pattern recognition, language, attention, perception, action, problem solving, and mental imagery. 21. 22. Traditionally, emotion was not thought of as a cognitive process, but now much research is being undertaken to examine the cognitive psychology of emotion. Research is also focused on one's awareness of one's own strategies and methods of cognition, which is called metacognition. The concept of cognition has gone through several revisions through the development of disciplines within psychology. Citation needed. Psychologists initially understood cognition governing human action as information processing. This was a movement known as cognitivism in the 1950s, emerging after the behaviorist movement viewed cognition as a form of behavior. 23. Cognitivism approached cognition as a form of computation, viewing the mind as a machine and consciousness as an executive function. 19. However, post-cognitivism began to emerge in the 1990s as the development of cognitive science presented theories that highlighted the necessity of cognitive action as embodied, extended, and producing dynamic processes in the mind. 24. The development of cognitive psychology arose as psychology from different theories, and so began exploring these dynamics concerning mind and environment, starting a movement from these prior dualist paradigms that prioritized cognition as systematic computation or exclusively behavior. 19. Piaget's theory of cognitive development. Edit. Main article, Piaget's theory of cognitive development. For years, sociologists and psychologists have conducted studies on cognitive development, i.e. the construction of human thought or mental processes. Citation needed. Jean Piaget was one of the most important and influential people in the field of developmental psychology. He believed that humans are unique in comparison to animals because we have the capacity to do abstract symbolic reasoning. His work can be compared to Lev Vygotsky, Sigmund Freud, and Erik Erikson, who were also great contributors in the field of developmental psychology. Piaget is known for studying the cognitive development in children, having studied his own 3 children and their intellectual development, from which he would come to a theory of cognitive development that describes the developmental stages of childhood. 25. Stage. Age or period. Description, 26. Sensorimotor stage. Infancy, 0–2 years. Intelligence is present, motor activity but no symbols, knowledge is developing yet limited, knowledge is based on experiences / interactions, mobility allows the child to learn new things, some language skills are developed at the end of this stage. The goal is to develop object permanence, achieving a basic understanding of causality, time, and space. Pre-operational stage. Toddler and early childhood, 2–7 years. Symbols or language skills are present, memory and imagination are developed, non-reversible and non-logical thinking, shows intuitive problem solving, begins to perceive relationships, grasps the concept of conservation of numbers, predominantly egocentric thinking. Concrete operational stage. Elementary and early adolescence, 7–12 years. Logical and systematic form of intelligence, manipulation of symbols related to concrete objects. Thinking is now characterized by reversibility and the ability to take the role of another, grasps concepts of the conservation of mass, length, weight, and volume, predominantly operational thinking, non-reversible and egocentric thinking. Formal operational stage. Adolescence and adulthood, 12 years and on. Logical use of symbols related to abstract concepts, acquires flexibility in thinking as well as the capacities for abstract thinking and mental hypothesis testing, can consider possible alternatives in complex reasoning and problem solving. Beginning of cognition. Edit. Studies on cognitive development have also been conducted in children beginning from the embryonal period to understand when cognition appears and what environmental attributes stimulate the construction of human thought or mental processes. Research shows the intentional engagement of fetuses with the environment, demonstrating cognitive achievements. 27. However, organisms with simple reflexes cannot cognize the environment alone because the environment is the cacophony of stimuli, electromagnetic waves, chemical interactions, and pressure fluctuations. 28. Their sensation is too limited by the noise to solve the cue problem. The relevant stimulus cannot overcome the noise magnitude if it passes through the senses. See the binding problem. Fetuses need external help to stimulate their nervous system in choosing the relevant sensory stimulus for grasping the perception of objects. 29. The shared intentionality approach proposes a plausible explanation of perception development in this earlier stage. Initially, Michael Tomasello introduced the psychological construct of shared intentionality, highlighting its contribution to cognitive development from birth. 30. This primary interaction provides unaware collaboration in mother-child DIDs for environmental learning. Later, Igor Valdanilov developed this notion, expanding it to the intrauterine period and clarifying the neurophysiological processes underlying shared intentionality. 31. According to the shared intentionality approach, the mother shares the essential sensory stimulus of the actual cognitive problem with the child. 32. By sharing this stimulus, the mother provides a template for developing the young organism's nervous system. 33. Recent findings in research on child cognitive development, 29, 31, 34, 35, 36, 37, 38, 39, 40, and advances in interbrain neuroscience experiments, 41, 42, 43, 44, 45, have made the above proposition plausible. Based on them, the shared intentionality hypothesis introduced the notion of preperceptual communication in the mother-fetus communication model due to non-local neuronal coupling. 27, 31, 33. This non-local coupling model refers to communication between two organisms through the copying of the adequate ecological dynamics by biological systems indwelling one environmental context, where a naive actor, fetus, replicates information from an experienced actor, mother. Due to intrinsic processes of these dynamic systems, embodied information, but without interacting through sensory signals. 27, 31, 33. The mother's heartbeats, a low-frequency oscillator, modulate relevant local neuronal networks in specific subsystems of both her and the nervous system of the fetus due to the effect of the interference of the low-frequency oscillator, mother heartbeats, and already exhibited gamma activity in these neuronal networks. Interference in physics is the combination of two or more electromagnetic waveforms to form a resultant wave. 27, 31, 33. Therefore, the subliminal perception in a fetus emerges due to shared intentionality with the mother that stimulates cognition in this organism even before birth. 27, 31, 33. Another crucial question in understanding the beginning of cognition is memory storage about the relevant ecological dynamics by the naive nervous system, i.e., memorizing the ecological condition of relevant sensory stimulus, at the molecular level and in gram. Evidence derived using optical imaging, molecular genetic and optogenetic techniques in conjunction with appropriate behavioral analyses continues to offer support for the idea that changing the strength of connections between neurons is one of the major mechanisms by which engrams are stored in the brain. 46. 2 or more possible mechanisms of cognition can involve both quantum effects, 47, and synchronization of brain structures due to electromagnetic interference. 48, 27, 31, 33. Common types of tests on human cognition. Edit. Serial position. Edit. The serial position effect is meant to test a theory of memory that states that when information is given in a serial manner, we tend to remember information at the beginning of the sequence, called the primacy effect, and information at the end of the sequence, called the recency effect. Consequently, information given in the middle of the sequence is typically forgotten, or not recalled as easily. This study predicts that the recency effect is stronger than the primacy effect, because the information that is most recently learned is still in working memory when asked to be recalled. Information that is learned first still has to go through a retrieval process. This experiment focuses on human memory processes. 49. Word superiority. Edit. The word superiority effect experiment presents a subject with a word, or a letter by itself, for a brief period of time, i.e. 40 ms, and they are then asked to recall the letter that was in a particular location in the word. In theory, the subject should be better able to correctly recall the letter when it was presented in a word than when it was presented in isolation. This experiment focuses on human speech and language. 50. Brown-Peterson. Edit. In the Brown-Peterson cohomology experiment, participants are briefly presented with a trigram, and in one particular version of the experiment, they are then given a distractor task, asking them to identify whether a sequence of words is in fact words, or non-words, due to being misspelled, etc. After the distractor task, they are asked to recall the trigram from before the distractor task. In theory, the longer the distractor task, the harder it will be for participants to correctly recall the trigram. This experiment focuses on human short-term memory. 51. Memory span. Edit. During the memory span experiment, each subject is presented with a sequence of stimuli of the same kind, words depicting objects, numbers, letters that sound similar, and letters that sound dissimilar. After being presented with the stimuli, the subject is asked to recall the sequence of stimuli that they were given in the exact order in which it was given. In one particular version of the experiment, if the subject recalled a list correctly, the list length was increased by 1 for that type of material, and vice versa if it was recalled incorrectly. The theory is that people have a memory span of about 7 items for numbers, the same for letters that sound dissimilar and short words. The memory span is projected to be shorter with letters that sound similar and with longer words. 52. Visual search. Edit. In one version of the visual search experiment, a participant is presented with a window that displays circles and squares scattered across it. The participant is to identify whether there is a green circle on the window. In the featured search, the subject is presented with several trial windows that have blue squares or circles and one green circle or no green circle in it at all. In the conjunctive search, the subject is presented with trial windows that have blue circles or green squares and a present or absent green circle whose presence the participant is asked to identify. What is expected is that in the feature searches, reaction time, that is the time it takes for a participant to identify whether a green circle is present or not, should not change as the number of distractors increases. Conjunctive searches where the target is absent should have a longer reaction time than the conjunctive searches where the target is present. The theory is that in feature searches, it is easy to spot the target, or if it is absent, because of the difference in color between the target and the distractors. In conjunctive searches where the target is absent, Reaction time increases because the subject has to look at each shape to determine whether it is the target or not, because some of the distractors, if not all of them, are the same color as the target stimuli. Conjunctive searches where the target is present take less time because if the target is found, the search between each shape stops. 53. Knowledge representation. Edit. The semantic network of knowledge representation systems have been studied in various paradigms. One of the oldest paradigms is the leveling and sharpening of stories as they are repeated from memory, studied by Bartlett. The semantic differential used factor analysis to determine the main meanings of words, finding that the ethical value of words is the first factor. More controlled experiments examine the categorical relationships of words in free recall. The hierarchical structure of words has been explicitly mapped in George Miller's WordNet. More dynamic models of semantic networks have been created and tested with computational systems such as neural networks, latent semantic analysis, LSA, Bayesian analysis, and multidimensional factor analysis. The meanings of words are studied by all the disciplines of cognitive science. 54. Metacognition. Edit. This section is an excerpt from Metacognition. Edit. Metacognition and self-directed learning. Metacognition is an awareness of one's thought processes and an understanding of the patterns behind them. The term comes from the root word meta, meaning beyond, or on top of. 55. Metacognition can take many forms, such as reflecting on one's ways of thinking, and knowing when and how oneself and others use particular strategies for problem solving. 55. 56. There are generally two components of metacognition: 1. Cognitive conceptions and 2. Cognitive regulation system. 57. 58. Research has shown that both components of metacognition play key roles in metaconceptual knowledge and learning. 59. 60. 58. Metamemory, defined as knowing about memory and mnemonic strategies, is an important aspect of metacognition. 61. Writings on metacognition date back at least as far as two works by the Greek philosopher Aristotle, 384–322 BC, on the soul and the parva naturalia. 62. Improving cognition. Edit. Main article, nootropic. Physical exercise. Edit. Aerobic and anaerobic exercise have been studied concerning cognitive improvement. 63. There appear to be short-term increases in attention span, verbal and visual memory in some studies. However, the effects are transient and diminish over time, after cessation of the physical activity. 64. People with Parkinson's disease has also seen improved cognition while cycling, while pairing it with other cognitive tasks. 65. Dietary supplements. Edit. Studies evaluating phytoestrogen, blueberry supplementation and antioxidants showed minor increases in cognitive function after supplementation but no significant effects compared to placebo. 66, 67, 68. Another study on the effects of herbal and dietary supplements on cognition in menopause show that soy and ginkgo biloba supplementation could improve women's cognition. 69. Pleasurable social stimulation. Edit. Exposing individuals with cognitive impairment, i.e. dementia, to daily activities designed to stimulate thinking and memory in a social setting, seems to improve cognition. Although study materials are small, and larger studies need to confirm the results, the effect of social cognitive stimulation seems to be larger than the effects of some drug treatments. 70. Other methods. Edit. Transcranial magnetic stimulation, TMS, has been shown to improve cognition in individuals without dementia 1 month after treatment session compared to before treatment. The effect was not significantly larger compared to placebo. 71. Computerized cognitive training. Utilizing a computer-based training regime for different cognitive functions has been examined in a clinical setting, but no lasting effects has been shown. 72. See also. Edit. Philosophy Portal. Psychology Portal. Cognitive Abilities Screening Instrument. Cognitive Biology. Cognitive Computing. Cognitive Holding Power. Cognitive Liberty. Cognitive Musicology. Cognitive Psychology. Cognitive Science. Cognitivism. Comparative Cognition. Embodied Cognition. Cognitive Shuffle. Information Processing Technology and Aging. Mental Chronometry, i.e., the measuring of cognitive processing speed. Nootropic. Outline of human intelligence, a list of traits, capacities, models, and research fields of human intelligence, and more. Outline of thought, a list that identifies many types of thoughts, types of thinking, aspects of thought, related fields, and more. Shared intentionality. References. Edit. Flood, Robert. De Triple. Anime Incorp. Vision. Tract. I, Sect. I, Lib. Ex in utriusque cosmi maioris silicitit minoris metaphysica, Physica et Technica Historia, Vol. 2 p. 217. Cognition. Lexico. Oxford University Press and Dictionary.com. Archived from the original on 15 July 2020. Retrieved 6 May 2020. Von Eckart B., 1996. What is Cognitive Science? Princeton, MA, MIT Press. pp. 4572. ISBN 9780262720236. A. B. Revlin R. Cognition, Theory and Practice. Little H. G., Scott R., 1940. Jones H. S., Mackenzie R., eds. A Greek-English Lexicon. Oxford, Clarendon Press via Perseus Project. Franchi S., Bianchini F., 2011. On the Historical Dynamics of Cognitive Science, A View from the Periphery. The Search for a Theory of Cognition, Early Mechanisms and New Ideas. Amsterdam, Redop I. p. 14. Matlin M., 2009. Cognition. Hoboken, N.J., John Wiley and Sons, Inc. p. 4. Eddy M.D. The Cognitive Unity of Calvinist Pedagogy in Enlightenment Scotland. Abraham Kovacs, ed., Reformed Churches Working Unity in Diversity, Global Historical, Theological and Ethical Perspectives, Budapest, L. Harmattan, 2016 4660. Eddy M.D., December, 2017. The Politics of Cognition, Liberalism and the Evolutionary Origins of Victorian Education. British Journal for the History of Science. 50, 46710.1007087417008741700086 PMID 2901930. A. B. Fuchs, Miller K.J., 2003. Psychology as a Science. Handbook of Psychology. 1. The History of Psychology 126-10.1002/047126438.5.WE0101. ISBN 0471264385. Zangwill L. 2004. The Oxford Companion to the Mind. New York, Oxford University Press. pp. 951952. Zangwill L. 2004. The Oxford Companion to the Mind. New York, Oxford University Press. p. 276. Brink T.L., 2008. Memory. Unit 7. Psychology, a student-friendly approach. p. 126. Madigan S., Ahara R., 1992. Short-term memory at the turn of the century, Mary Whitten Calkins Memory Research. American psychologist. 47, 21714-10.1037-4-0003-066x.47.2.170. A. B. Matlin M., 2009. Cognition. Hoboken, N.J., John Wiley & Sons, Inc. p. 5. René Descartes. Internet Encyclopedia of Philosophy. Retrieved 2 April, 2020. A. B. Sternberg R.J., Sternberg K., 2009. Cognitive Psychology, 6th ed. Belmont, C.A., Wadsworth Engage Learning. ISBN missing. Blom Ergo, 2011. Concepts of Cognition for Cognitive Engineering. International Journal of Aviation Psychology. 21, 185104010.1080/1050814.2011.537561. S2 SID 144876967. ABC Paco Calvo, Antoni Gomila, eds. 2008. Handbook of Cognitive Science, An Embodied Approach. Amsterdam, Elsevier Science. ISBN 978-0-08-091487-9. OCLC 3183537881. Lakoff, George, 2012. Explaining Embodied Cognition Results. Topics in Cognitive Science. 4.4773785.10.1765.2012.012222.x. ISSN 1756-8757. PMID 2296190. S2 SID 189781114. Corrin, Stanley, Lawrence M. Ward, and James T. Innes. 1999. Sensation and Perception, 5th ed. Harcourt Brace. ISBN 978-0-470-00226-1. p9. Best J.B., 1999. Cognitive Psychology, 5th ed. pp. 15-17. ISBN missing. Pieszczynski, Tom, Greenberg, Jeff, Kuhl, Sander, Solomon, Sheldon, 2010. Experimental Existential Psychology, Coping with the Facts of Life. In Fisk, Susan T. Gilbert, Daniel T. Lindsay, Gardner, eds. Handbook of Social Psychology. Hoboken, N.J., John Wiley & Sons. pp. SOCPSI 001020. do 10.1024/9780470561119.socpsi 001020. ISBN 978-0-470-56111-9. Zielazo, Philip David, Morskovich, Morris, Thompson, Evan, eds. 2007. The Cambridge Handbook of Consciousness. do 10.1017/PBO 9780511816789. ISBN 9780511816789. Cherry K. Jean Piaget Biography. The New York Times Company. Archived from the original on 19 April 2016. Retrieved 18 September 2012. Park Road, Gavin M. 2009. Child Psychology, A Contemporary Viewpoint, 7th ed. Boston, McGraw-Hill. ISBN missing. ABCDEF Valdana Luff, Igor, 2023. Shared Intentionality Modulation at the Cell Level, Low-Frequency Oscillations for Temporal Coordination in Bioengineering Systems. OBM Neurobiology. 7. 4117 do 10.21926/obm.neurobiol.2304185. S2 SID 2637222179. Valdana Luff, Igor, 2022. Smartphone in Detecting Developmental Disability in Infancy, a Theoretical Approach to Shared Intentionality for Assessment Tool of Cognitive Decline and E-Learning. Intelligent Computing. Lecture Notes in Networks and Systems. Volume 508 pp. 305315. do 10.1007/9783031104671_19. ISBN 978-3-031-104666-4. AB Valdana Luff, Igor, Mihailova, Sandra, 2022. A New Perspective on Assessing Cognition in Children Through Estimating Shared Intentionality. Journal of Intelligence. 10. 221 do 10.3390/Intelligence 100200021. ISSN 2079-3200. PMC 9036231. PMID 354666234. Tomasello, M. Becoming Human, A Theory of Ontogeny. Cambridge, Massachusetts, Harvard University Press, 2019. ISBN missing, page needed. ABCDEFG Valdana Luff, 2023. Theoretical Grounds of Shared Intentionality for Neuroscience in Developing Bioengineering Systems. OBM Neurobiology 2023, 7, 156, do 10.2196/obm.neurobiol.2301156. Valdana Luff, Igor, Mihailova Sandra. 2021. Neuronal Coherence Agent for Shared Intentionality, a hypothesis of neurobiological processes occurring during social interaction. OBM Neurobiology 2021, 5, 426, do 10.2196/obm.neurobiol.2104113. ABCDEF Valdana Luff, Igor, 2023. Low-frequency oscillations for non-local neuronal coupling in shared intentionality before and after birth, toward the origin of perception. OBM Neurobiology. 7. 4117-10.21926/obm.neurobiol.2304192. S2 SID 2650022516. Castillo, U. Bacchio, C. Zoya, S. Nilani, C. Sartri, L. Blasson, L. D. Ottavio, G. Bulgarani, M. Gallis, V. 2010. Wired to be Social, The Ontogeny of Human Interaction. PLOS 1, 5, 10, P.E13199. Kyselewski, B.C. 2016. Fetal auditory processing, implications for language development. Fetal development. Research on brain and behavior, environmental inuences, and emerging technologies, 133152. Lee, G.Y.C., Kyselewski, B.S. 2014. Fetuses respond to father's voice but prefer mother's voice after birth. Developmental Psychobiology, 56, 111. Hepper, P.G., Scott, D. Shahidullah, S. 1993. Newborn and Fetal Response to Maternal Voice. Journal of Reproductive and Infant Psychology, 11, 147153. Le Canuet, J.P., Grenier de Fer, C. Jacquet, A.Y., Caponi, I. Ledru, L. 1993. Prenatal discrimination of a male and a female voice uttering the same sentence. Early Development and Parenting, 2, 4217228. Hepper P. 2015. Behavior during the prenatal period, adaptive for development and survival. Child Development Perspectives, 9, 13843 to 10.1111/GDIP.1210.4. Jardri, R. Hof-Lindebarge, V. Delian, P. Pruvo, J. P. Thomas, P. Pins, D. 2012. Assessing Fetal Response to Maternal Speech Using a Non-Invasive Functional Brain Imaging Technique. International Journal of Developmental Neuroscience, 2012, 30, 159161. Do 10.1000/j.ijdevnew.2011.11.002. Lu J, Zhang R, Zai, Lin Y, Chen D, Lu Y, It al. August 2023. Shared intentionality modulates interpersonal neural synchronization at the establishment of communication system. Communications Biology. 6, 1-832 do 10.1038/S42003-023-051970Z. PMC 104152555. PMID 37563301. Painter Dr. Kim J.J., Renton A.I., Mattingly J.B., June 2021. Joint control of visually guided actions involves concordant increases in behavioral and neural coupling. Communications Biology. 4, 1-816 to 10.1000/S4203-021-02319-3. PMC 82422020. PMID 34188170. Hu Y, Pan Y, Shi X, Caiq, Li X, Cheng X, March 2018. Interbrain synchrony and cooperation context in interactive decision making. Biological Psychology. 133, 5462. Do 10.1016/j.biopsycho.2017.12.005. PMID 29292232. S2 SID 4685960. Fishburne F.A., Murty V.P., Lukowski Co., MacGillivray C.E., Bemis L.M., Murphy Me, it al. September 2018. Putting Our Heads Together, Interpersonal Neural Synchronization as a Biological Mechanism for Shared Intentionality. Social Cognitive and Affective Neuroscience. 13. 88418449 do 10.1093/scan/NSY060. PMC 6123517. PMID 3006030. Szymanski C., Pesquitara, Brennan A., Podikes D., Inns JT, Brick TR, it al. May 2017. Teams on the same wavelength perform better. Interbrain phase synchronization constitutes a neural substrate for social facilitation. Neuroimage 152, 425436. Do 10.1016/j.neuroimage.2017.03.013. HDL 11858//00001M0000002D059A1. PMID 28284802. S2 SID 38078834. Takeki, T. Duskiewicz, A.J., Morris, R.G. 2013. The Synaptic Plasticity and Memory Hypothesis, Encoding, Storage and Persistence. Philostrans are Soklond B. Biol SCI. 2013 December 2, 369, 1633 20130288. Do 10.1093/rstb.2013.028. PMID 242981667, PMC 38439897. Kaskens, C.M. Perez, D.L. 2022. Experimental Indications of Non-Classical Brain Functions. Journal of Physics Communications, 6, 10, 105001. Do 10.1088/2389-6528/AC94B https://iopscience.io.org/article/10.1088/2399-6528/AC94B/meta. Hans Ulme, S. Axmacher, N. Inman, C.S. 2019. Modulating Human Memory via Entrainment of Brain Oscillations. Trends in Neurosciences, 42, 7, 485499. Do 10.1016/j.tins.2019.04.004. Supranantum, May 2001. Distinctiveness and serial position effects in tonal sequences. Perception and Psychophysics. 63, 473775 to 10.3758/BF03194434. PMID 1143672. Kruger, November 1992. The Word Superiority Effect and Phonological Recoding. Memory and Cognition. 20, 6685694 do 10.3758/BF03202718. PMID 1435271. Carrot Nairn J., Whiteman H., Kelly M., 1999. Short-term forgetting of order under conditions of reduced interference, PDF. Quarterly Journal of Experimental Psychology of 52, 241251. Do 10.1080/713755806. S2 SID 157138857. Archived from the original, PDF, on 30 July 2022. Retrieved 9 January 2018. Carrot Macy P., Hasher L., Kane M.J., September 1999. The Role of Interference in Memory Span. Memory and Cognition. 27, 5759767 do 10.3758/BF03198529. PMID 105400805. Carrot Wolf J., Cave K., Franzel S., 1989. Guided Search, an alternative to the feature integration model for visual search. Journal of Experimental Psychology, Human Perception and Performance. 15, 3419433. Site CX 10.1.1.551.1667. Do 10.1037/0096-1523.15.3.419. PMID 2527952. Carrot Pinker S., Bloom P., December 1990. Natural Language and Natural Selection. Behavioral and Brain Sciences. 13, 4707727 do 10.1017/01405255x00081061. S2 SID 61676614. Carrot A. B. Metcalf, J., and Shimamura, A. P. 1994. Metacognition, Knowing About Knowing. Cambridge, MA, MIT Press. Carrot Flavel, J. H. 1979. Metacognition and Cognitive Monitoring. A New Area of Cognitive Development Inquiry. American Psychologist. 34, 10.906911 do 10.1037/0037-066x.34.10.906. Carrot Shaw, Gregory, 1998. Promoting General Metacognitive Awareness. Instructional Science. 26, 113125. Do 10.1030/10030442310033. S2 SID 157154118. Carrot A. B. Hartelt, T. and Martins, H. 2024. Influence of Self-Assessment and Conditional Metaconceptual Knowledge on Students' Self-Regulation of Intuitive and Scientific Conceptions of Evolution. Journal of Research in Science Teaching, 61, 5, 1134-1180. https://do.org/10.1002/t.21938. Carrot Borkowski, J.G. 1992. Metacognitive Theory, a Framework for Teaching Literacy, Writing, and Math Skills. Journal of Learning Disabilities. 25, 4. Hamill Institute on Disabilities, 253257. Do 10.101177/0022219492025004006. PMID 157335. S2 SID 10031331. Gustone, R.F. and Mitchell, I.I. 2005. Metacognition and Conceptual Change. In J.J. Mintzes, J.H. Wondersi and J.D. Novak, eds, Teaching Science for Understanding, A Human Constructivist View, pp 133163. Academic Press. Dunlosky, J. and Bjork, R. eds. Handbook of Metamemory and Memory. Psychology Press, New York, 2008. Coleman, Andrew M. 2001. Metacognition. A Dictionary of Psychology. Oxford Paperback Reference, 4 ed. Oxford, Oxford University Press, published 2015. p. 456. ISBN 9780199657681. Retrieved 17 May 2017. Writings on metacognition can be traced back at least as far as De Anima and the Parva Naturalia of the Greek philosopher Aristotle, 384 to 322 BC. Sanders L.M., Hortobagite, La Bastard van Gemert S., van der Zee, van Huvelen M.J., 10 January 2019. Regnors J.P., ed. Dose-response relationship between exercise and cognitive function in older adults with and without cognitive impairment, a systematic review and meta-analysis. PLOS 1. 14, 1E02100036. Bibcode 2019 PLOS 014100036S. Do 10.1341/journal.pwn.02100036. PMC 6328108. PMID 3062961. Young J., Angevarian M., Rusted J., Tabe N., et al. Cochrane Dementia and Cognitive Improvement Group, April 2015. Aerobic exercise to improve cognitive function in older people without known cognitive impairment. The Cochrane Database of Systematic Reviews. 2015, 4 CD 005381 to 10.1002/1465185.cd 005381.pub 4. PMC 1055455. PMID 259000537. Hazami, Audrey. Altman, Laurie J.P., Stijamola, Elizabeth, Bowers, Dawn, Lee, H.Y. Okun, Wilson, Jonathan, Okun, Michael S. Haas, Chris J. April 2017. Improved cognition while cycling in Parkinson's disease patients and healthy adults. Brain and Cognition. 113, 2331. Do 10.1016/j.bang.2017.01.002. PMC 5346468. PMID 28088064. Barfoot K.L., Meiji, Lamport D.J., Ricketts J., Riddell P.M., Williams Centimeter, October 2019. The Effects of Acute Wild Blueberry Supplementation on the Cognition of 7-10-year-old School Children. European Journal of Nutrition. 58, 7 2911 2920 do 10.1000394018-018-1843-6 PMC 6768899 PMID 303278868 Carrot Thongs or JJ, How PR, Wong RH, September 2017. Does phytoestrogen supplementation improve cognition in humans? A systematic review. Annals of the New York Academy of Sciences. 1403, 115163. Bibcode 2017 NYSA 1403 150T. Do 10.1111/NYS.13459. PMID 289459939. S2 SID 252807060. Carrot Sokolafan, Pavlova Ma, Kloster half NS, Inc. P. December 2013. Chocolate and the Brain, Neurobiological Impact of Cocoa Flavanols on Cognition and Behavior. Neuroscience and Biobehavioral Reviews. 37, 10 pt2 2445 2453 do 10.1016/j.newbiorev.2013.06.013. PMID 238107191. S2 SID 17371625. Carrot Clement, Yuri N. Anak Poya, Iho, Hung, Xiaokei. Ernst, Edzard, March 2011. Effects of herbal and dietary supplements on cognition in menopause, a systematic review. Maturitas. 68. 3256263 do 10.1016/j.maturitas.2010.12.005. PMID 21237589. Carrot Woodsby, Orgwer, Spector A, Oral M, it al. Cochrane Dementia and Cognitive Improvement Group, February 2012. Cognitive stimulation to improve cognitive functioning in people with dementia. The Cochrane Database of Systematic Reviews, 2CD005562 do 10.1002/1465185.CD005562.pub2. PMID 223368813. S2 SID 70867882. Carrot Trung J, Hangen Ua, Jobert S, De Groot C, Magia Constain B, Kibred M, it al. September 2019. Transcranial magnetic stimulation improves cognition over time in Parkinson's disease. Parkinsonism and related disorders. 66, 38. Do 10.1016/j.parkreldis.2019.07.006. PMID 31300260. S2 SID 1963505357. Carrot Gates NJ, Rutgers AW, DI Nijo M, Karim S, Chong Lai, March E, it al. Cochrane Dementia and Cognitive Improvement Group, February 2020. Computerized cognitive training for 12 or more weeks for maintaining cognitive function in cognitively healthy people in late life. The Cochrane Database of Systematic Reviews. 2020, 2CD012277 do 10.1002/1465185.CD012277.pub3. PMC 7045394. PMID 321049114. Further reading. Edit. Ardilo, 2018. Historical Development of Human Cognition. A Cultural Historical Neuropsychological Perspective. Springer. ISBN 978-9811068867. Coroness, Ward L. M., Inns J. T., 1999. Sensation and Perception. Harcourt Brace. p. 9. ISBN 978-0-470-00226-1. Licken W. G., ed. 1999. Mind and Cognition, An Anthology, 2nd ed. Malden, Ma., Blackwell Publishing. Stanovic, Keith, 2009. What Intelligence Tests Miss, The Psychology of Rational Thought. New Haven, CT Yale University Press. ISBN 978-0-300-12385-2. External links. Edit. Wikiversity has learning resources about cognition. Wikibooks has a book on the topic of cognitive psychology. Look up Cognition in Wiktionary, the free dictionary. Cognition, an international journal publishing theoretical and experimental papers on the study of the mind. Information on music cognition, University of Amsterdam. Cognity.nl, archived 19 October, 2011 at the Wayback Machine. Information on cognition research, Netherlands Organization for Scientific Research, NWO, and University of Amsterdam, UVA. Emotional and Decision Making Lab, Carnegie Mellon, EDM Lab. The Limits of Human Cognition, an article describing the evolution of mammals' cognitive abilities. Half-heard phone conversations reduce cognitive performance. The Limits of Intelligence, Douglas Fox, Scientific American, 14 June, 2014, 2011. V. T. E. Mental Processes. Cognition. Association. Awareness. Cognitive flexibility. Cognitive liberty. Forecasting. Affective. Foresight. Comprehension. Consciousness. Critical thinking. Decision making. Imagination. Intuition. Problem solving. Methods. Strategies. Prospection. Perception. A modal. Color. RGB model. Depth. Form. Haptic, touch. Perception as interpretation. Peripheral. Social. Sound. Harmonics. Pitch. Speech. Visual. Memory. Consolidation. Encoding. Storage. Recall. Other. Attention. Experiential avoidance. Higher nervous activity. Intention. Ironic process theory. Learning. Mental fatigue. Relational frame theory. Mental set. Thinking. Thought suppression. Volition. V. T. E. Human intelligence topics. Types. Collective. Emotional. Intellectual. Linguistic. Multiple. Social. Spatial, visuospatial. Abilities, traits. And constructs. Cognition. Cognitive liberty. Communication. Creativity. Fluid and crystallized intelligence. G-factor. Intellect. Intelligence quotient. Knowledge. Learning. Memory. Problem solving. Reasoning. Skill. Thought, abstraction. understanding, visual processing, models and theories, Cattell-Horn-Carroll theory, fluid and crystallized intelligence, multiple intelligences theory, pass theory, three-stratum theory, triarchic theory, areas of research, evolution of human intelligence, heritability of IQ, psychometrics, intelligence and environment /fertility /height /health /longevity neuroscience personality race /sex, outline of human intelligence /thought, authority control databases, national, Germany, United States, France, BNF data, Japan, Czech Republic, Israel. Retrieved from https://en.wikipedia.org/w/index.php Cognition &olded =12538595534. Categories: Cognition, Cognitive psychology, Cognitive science, Mental processes, Thought. Hidden categories: articles containing Latin language text, pages with missing ISBNs, Wikipedia articles needing page number citations from August 2024. Use American English from July 2023. All Wikipedia articles written in American English. Articles with short description. Short description is different from Wikidata. Articles containing Ancient Greek to 1453 language text. All articles with unsourced statements. Articles with unsourced statements from August 2024. Articles with excerpts. Web archive template Wayback Links. This page was last edited on the 28th of October, 2024, at 7:42 UTC. Text is available under the Creative Commons Attribution Share Alike 4.0 license. Additional terms may apply. By using this site, you agree to the terms of use and privacy policy. Wikipedia registered trademark symbol is a registered trademark of the Wikimedia Foundation, Inc., a non-profit organization. Privacy policy. About Wikipedia. Disclaimers. Contact Wikipedia. Code of conduct. Developers. Statistics. Cookie statement. Mobile view.